What's going on, everybody? Welcome to Everything EE. Today we're doing a mesh analysis example. This will probably be sort of example one in a series of maybe two or three other examples that get a little bit more challenging as we go along. But the thing here to remember when we're doing mesh analysis is that we're really leveraging KVL, or Kirchhoff's voltage law, that states that the voltages around a closed loop are gonna equal zero. So we can check this out, right? We have four voltage sources. One's 50 volts, one's 25 volts, and one's 150 volts, and finally 20 volts. And then we have corresponding series resistors of 10 ohms, 20 ohms, 30 ohms, and 25 ohms. We have another voltage source hanging out down here, this 100 volt source. It kind of mixes up things, right? Because everything else that's in parallel with these branches are resistors, and here they threw in a little curveball for us, so that'll make things interesting. And then finally, I've chosen my currents that I'm going to be using as a reference. So I have this I1 here, I2, I3, and I4. And when we're doing Kirchhoff's voltage law, right, we're getting voltages around a loop. So when we're looking at these resistors, we're going to use the currents that are going through the resistors to describe the voltage across them. So we're using V equals IR. Okay, so let's break this down. Oh, and one more thing to note. You guys might be wondering, hey, why'd you choose all of your currents to be going in clockwise orientations? And that's just how I chose it. Once we actually get the voltage or the currents here, we'll see that, if it has a negative sign, that means the current's actually flowing in the opposite direction of what I chose to reference it as. So if it's positive, that means the current is actually flowing in the direction that I said. So all that to be said, the math will work out in any direction you choose for the current. Okay, so I just went ahead and went with clockwise, and so we're gonna go from there. So starting off with the first current loop, I1, we have mesh, we'll call that mesh 1. And that's going to be starting with the 150 volt source. That's going to be plus 150 volts. So we just went through here. Now we're going through this resistor. So what's the voltage across a resistor? It's V equals IR. So we know R is 30. What's the current? Well, we're going to define the current for this loop as I1 minus I4. So it's basically, since this branch is in between two loops, we're going to define the current going through this loop as the current that we're analyzing, I1, minus whatever other current it's sharing in that branch, which is I4. Okay, so that takes care of the 30 ohm element. So we're moving on to the 100 volt element. It's minus here, because we're coming around, so we're going through the minus terminal. So we have minus 100, and then coming back around, we're at the 25 ohm resistor. So plus V equals IR. So R is 25 times, this time we have I1 minus I2. Okay, and finally we have the 20 volt source, so it's minus again because we're going through the negative terminal. We're coming around here, so we're going minus to plus, so it's minus 20 volts. And remember, all of the voltages around a closed loop, all of the voltages around a closed loop are going to equal 0 based on Kirchhoff's voltage law. Okay, so let's combine some things here. We have 100 minus 100 minus 20. That's going to leave us 30. Then we can combine, so takes care of 150 minus 100 is 50, minus 20 is 30. All right, so we've got that combined. Now let's combine like terms. So we have this I1 here, so it's being multiplied by 30. And then this other I1 here is being multiplied by 25. So we'll end up with plus 55 I1. Okay, let's combine. Oh, that's the only one we combined, right? So we have, then we're left over with a minus 25 I2, and then a minus 30 I4 equals 0. And we can finally move over this 30. So we end up with 55 I1 minus 25 I2 minus 30 I4 is equal to minus 30. That's going to be our first equation. Okay, so we're going to end up with 4 equations for unknowns. Okay, so let's move along here. Let's go for mesh 2. So we're looking, let's start with this 5 ohm resistor. So we have the voltage across that resistor is V equals IR, which is 5 times I2. Moving along to the 10 ohm resistor, we're going to have V equals IR, so plus 10 times the current going through this shared branch we define as I2 minus I3. Moving on to the 50 volt source, plus 50. Around to the 20 volt source, and now we're going through the positive terminals, so it's plus 20. And finally ending with the 25 ohm, which is V equals IR, so 25 times the shared current between the two branches, which is I2 minus I1. And that's going to equal to 0. Okay, so let's go ahead and combine like terms. We can start with the just the whole numbers of 50 plus 20. Makes us 70. Let's look at I1. So here we just have one I1 term that is paired with this 25. So we'll get minus 25 I1. Then let's look at I2. So we have 25 I2 and 10 I2. It's going to give us plus 35 I2. Oh, and then we have another I2 right here of 5. So that'll give us a grand total of 40 I2. Okay, let's move on to I3. So we've got a minus 10 I3. And I believe that's all of our terms, so that equals 0. And let's move the 70 over, so we'll have minus 25 I1 plus 40 I2 minus 10 I3 equals negative 70. This is our second equation. Okay, moving on to mesh 3. We've got, starting with the 15 ohm resistor, we've got 15 I3 plus the 20 ohm resistor, 20 I3 minus I4 plus the voltage source of 25 minus the voltage source of 50 plus 10 times I3 minus I2. Okay, that equals 0. And let's combine like terms. So 25 minus 50 is minus 25. Let's start with our highest I. We've got I2. That's a minus 10 I2. We've got I3. We've got 15 I3. We've got 20 I3. That's 35 I3. And then 10 I3. That's 45 I3. Okay. And finally we have the minus 20 I4 equals 0. And then finally let's write it as minus 10 I2 plus 45 I3 minus 20 I4 equals 25. That's 3. All right, finally, mesh 4. We've got, starting with a 35 ohm resistor, we have 35 I4 going to the 30 ohm resistor plus 30 times I4 minus I1 through the negative terminal of the 150 volt source, so minus 150. Again, through the negative terminal of the 25 volt source, so minus 25. And then finally ending up with the 20 ohm resistor, so plus 20 I4 minus I3. So then let's combine like terms. We've got negative 150 minus 25, so we have minus 175. We've got an I1, so we got minus I1. Minus 30 I1. Takes care of that. 3, we have 1 I3 here, so minus 20 I3. And then finally we have 3 I4, so 35 plus 30 is 65, plus 20 is 85. Plus 85 I4. So we're gonna combine like terms here, and we're gonna get minus 30 I1 minus 20 I3 plus 85 I4 equals, taking this 175 over, it equals 175. So that is our fourth equation. Okay. So we're going to use the TI-89 titanium. It's simultaneous equation solver. So pop over to the link in this video to see how to do simultaneous equation solving with the TI-89. It's a great tool to use when you're doing these kinds of problems. Actually chugging these equations out or it's kind of out of the scope of this problem. This is a mesh analysis problem, so we're gonna go ahead and just use the simultaneous equation solver, and what we get from that is I1, I2, I3, and I4. Each one of those is going to be equal to, first one we have 0.2139. I2 we have minus 1.2755. I3 we have 1.3633. And the last one we have 2.4551. And these are all amps. Don't forget to label your units. Professors are sticklers for that. So these are all amps. So we've arrived at this final answer. You can see here that the directions that I chose, I1, it is in the direction that I chose because it's positive, and so are I3 and I4. And I2, it's showing me that it's negative, so it's actually going in the opposite direction that I chose. So this is kind of what I talked about before. The math works out. You know, once you choose your reference, the math is going to work out, and it's going to tell you if you chose the right direction. And in the end, you can specify like, hey, this is the direction I chose. It's negative, so it's actually going the other way. So it's just nice that the math works out. You just need to choose a reference direction and go with it and just follow through with it. All right. Thank y'all so much for watching this video. Please like and subscribe. Any questions, post down in the comments, and let me know if you have any other problems you'd like to work out. Thank y'all. Have a great day.